All right, so if we take a look at number one, they want to know which statement is false about the graph. And be careful, because sometimes they ask false, sometimes they ask true. Okay, so, you can graph this in your calculator if you want. If you go to y equals and plug in 1/8 to the x power, you'll see that your graph is going to look something like that. Okay, this is exponential decay. All right, and I just want to point out the y-intercept is at 0, 1. Okay, and if you recall this graph, what happens is this graph comes closer and closer and closer to the x-axis, but it never actually reaches it. Okay, so let's go through the choices. Which is false? Okay, so choice 1 says the domain is negative infinity to positive infinity. Well, the domain is your x values. And that's a true statement. I mean, there's no limit with the x values. Like this arrow means the x values are going to continue to get bigger and bigger and bigger, right? This graph is going to go to the right forever. And then even the negative x values, I mean, even though this arrow is pointing up, isn't it still going to the left? There's not going to be any limit as to how far to the left this graph can go. Is it going to grow faster? Is it going to go up a lot faster than it goes to the left? Yes, but it's still going to continue to use all these x values. And to be honest, if you want to look in your calculator, go to the table of values. If you scroll all the way up, well, not all the way up, but if you scroll up pretty far and scroll down pretty far, if you notice it never says error next to any of the x values, that means you can use them all. All right, so that's a true statement, so that's not our answer. All right, choice number 2 says the graph is always decreasing. Well, that's true. You read a graph from left to right. As you go further and further you go to the right, the graph is getting lower and lower and lower. It's never going to actually hit or touch, this x-axis, but it is going to get closer and closer to it. So that's also a true statement, so that's not our answer. All right, the third one says the graph passes through 0, 1. It totally does. That's what I just plotted right here. So that one's true, so that's not our answer. So I'm assuming choice 4 is the false statement, but let's just make sure. The graph has an asymptote at x equals 0. Okay, the asymptote is the line that the graph comes closer and closer to but never reaches it. So in this case, the asymptote is the x-axis. Now the equation of any horizontal line is y equals, not x equals. So here the equation of the asymptote should be y equals 0, not x equals 0. So that's what makes choice 4 false. All right, so let's take a look at number 2. Again, they want to know which statement about the graph is false. So they're both asking false. All right, so if you go to y equals in your calculator. Now remember, if you want to graph something with a different base, okay, you're going to go to y equals, and you're going to hit the math button, and you could either scroll up or down. It's faster to scroll up until you see where it says log base. Okay, I think it's letter A. And you're just going to choose that and make your base a 6, and then you could put an x there. So when you graph that, this is what your graph's going to look like. Okay, and this time I'm just going to put, this one has an x-intercept this time. So it goes through the point 1, 0, right? Over 1, up 0. Okay, so which statement is false? Okay, choice 1. The asymptote has the equation x equals 0. Well, again, just like the last one, the asymptote is the line that the graph comes closer and closer to but never reaches. So here, see how the further you go to the left, it's going to come closer and closer and closer to the y-axis but never reach it? Okay, the equation of the y-axis, the equation of any vertical line is x equals wherever it crosses to the x-axis at, which is 0. So the equation of this y-axis is x equals 0. So that is the asymptote. That's true, so that's not our answer. Okay, choice 2. The graph has no y-intercept. It's not ever going to touch the y-axis, so that is a true statement. It has no y-intercept. All right, choice 3. The domain is negative infinity to positive infinity. All right, well, that's actually our false statement, because remember, domain is the x values. If you notice, we're going to use all the x values on the positive portion of the x-axis. But see these negative x values? The graph is never going to reach any of these, okay? So the domain doesn't include negative values. It also doesn't even include x equals 0, because this graph will never reach when x equals 0. So this is the false statement. And you know what else you could do? If you go into your table of values, like its second graph, what you'll notice is that when you scroll up the table, when x equals 0, when x equals -1, when x equals -2, and so on, all the y values will say error. So that's telling you you can't have a domain going from negative infinity to positive infinity. Okay, x only uses the positive x values, okay? And choice for the range, we'll just go through it. That's a true statement, so that's not our answer, because the range is the y value is how far up and how far down it goes. Okay, this arrow tells us it's going to go all the way down to negative infinity. And then this arrow, even though it's like going to the right a lot faster than it's going up, it's still going up. It's going to continue to grow and get higher and higher and higher, so it will go up to positive infinity. All right, number 3, solve for x. All right, well, whenever we're given an equation where there's log on one side of the equation and not the other, this is where we do circle the base and run the race. So what happens is this x becomes the base on the right-hand side of the equation, okay? So we have this x is our base, making this now our exponent, okay? And then what happens is, because we move this base, it's no longer holding the word log up, so we just take this 4 and bring it straight on down. So it gives us 4 equals x to the negative 2/3 power. Okay, so now all we have to do is just solve this. So if you want to get rid of this exponent on the x, we're going to raise both sides of the equation to the reciprocal power. So the reciprocal of negative 2/3 would be negative 3/2. Okay, you just take it and literally flip it upside down. And since it's negative, you want to keep it negative, because what happens is, over here, a negative times a negative is a positive. And then this 2 on top cancels with the 2 on bottom, and this 3 on top cancels with the 3 on bottom, just leaving us with x to the positive first power, or just x. Okay, this, you can either figure out what that's equal to by hand, or if even, I mean, you could literally, if you want, plug that in your calculator. And when you do, it'll give you one of 2 answers. You could either write it as a decimal. So if you do it in your calculator, it might give you this, 0.125. Or if you want to hit math, enter, enter, it'll give you 1/8. Okay? If you did do it by hand, I mean 4 to the negative 3/2 power, let me just do that off to the side. Okay, we know if we have a negative exponent, we can make it positive by moving this entire term to the denominator of a fraction. Okay, so that makes our exponent positive. And then I'll put a 1 on top as the placeholder. All right, so this would be 1 over, now remember, power over root. So it's going to be the square root of 4 to the 3rd power. So the square root of 4 to the 3rd power. So 1 over the square root of 4 is 2, and 2 to the 3rd power is 8. Okay, so if you did it by hand, that's where we got that 1/8 from. Okay, and number 4, so they give us this equation, and it says then t equals, okay, so what they're asking us to do is solve for t. All right, so I'm going to rewrite this so I have a little bit more room. And we know that in order to solve for t, we need, since it's an exponent, we need to get the base that contains that exponent by itself. So I need to get, this is the base e to this power. I need to get the e by itself. So I need to get rid of this x. So since it's x times e to this power, the opposite of times, the opposite of multiplication is division. So I'm going to divide both sides of the equation by x. And then that'll leave me with that base of e all by itself. So e to the yt power equals z over x. Now, we want to get rid of the e. We know to get rid of an e, we put ln in front of both sides of the equation. Because what happens is, ln of e to this power is just equal to whatever the power is, yt. Okay, so I'm going to just do that, and I'm going to bring down my yt. So yt equals ln of, I'm going to put this in parentheses, because I see that's what they're doing in the answer choices. Okay, and then finally, to get the t all by itself, we're just going to divide both sides by the y that's in front of it that it's being multiplied by. So it leaves us with t equals, and I'm just rewriting this, ln of z over x, and that whole thing is divided by y. Okay, so actually I see that right there in choice number 4. Okay, so if we take a look at number 5, it says the number of houses in Destin, Florida grows every year according to this function that they give us here. Where H represents the number of houses since January of 2010. Okay, the first thing they want us to do in part A is to explain what the numbers 880 and 1.024 represent in this function. All right, well, 880 is in the spot where the initial amount goes, and since we're talking about the number of houses, and the beginning time was January 2010, 880 represents the number of houses in Destin, Florida in January of 2010. Okay, so there we go. So now the next one, the 1.024, okay, that's within the parentheses. Now we know within the parentheses, right, this number always represents 1 plus the rate. So since 1 plus 0.024 is what gives us 1.024, that means the rate, I can't really see that decimal, let me make that a little bigger. It means the rate is equal to 0.024. Now if we want to change that to a percent, we take the decimal and move it over twice. So this is actually equal to a rate of 2.4%. Now, let's just think about what that means. So if the rate is positive, right, 2.4%, what that means is the number of houses is growing by 2.4% per year. Okay, every single year, not just once, per year since January of 2010. And you could say in Destin, Florida if you want, that's up to you. Okay, so let me just do that. So 1.024 represents a growth rate in the number of houses in Destin, Florida by 2.4% per year. And it's super important to put per year because it happens every year. It's not just a one-time thing. Okay, part B, in terms of quarterly growth rate. So let me just see, quarterly growth rate. So there's 4 quarters in a year. So what that means is this is happening 4 times per year. Okay, so anyway, in terms of quarterly growth rate, the number of houses in Destin, Florida since January 2010 can be best approximated by which of the following functions? Okay, so what I did was I just copied this function from part A right there. Or not from part A, but from above. And if this represents, T is years. So this represents a yearly growth rate by 2.4%, right? That's what we put in this first part. It increases by 2.4% per year. They want to know how much is it going to increase by each quarter. So since there's 4 quarters in a year, in front of the T, we put the number of times it's going to grow, number of quarters in a year. So I'm going to put the 4 right in front of the T. Now to compensate for doing that, we put the reciprocal of 4, so 1 over 4, inside the parentheses. So I'm going to put 1/4 here. Okay, so now at this point, I'm just going to bring most everything down, but in my calculator, I'm going to plug in what's in the parentheses. So in my calculator, I'm plugging in 1.024 to the 1/4 power. And when I do, I get I'm just looking at the answer choices to see what to round to. 0059, and I'm going to bring down this 4t power. Okay, because remember, this 4t represents 4 times per year. So 4 times per year, this is going to be the growth rate. Okay, so if we look here, this would be choice 2. Okay, letter C is pretty similar. So let me just start off with the same equation as we did from the very beginning of the problem. Okay, so all I did was I just wrote the equation from the top of the page, right? And now in part C, they're saying if growth rate is calculated every 10 years. Okay, so it's only being calculated once every 10 years. So I think of that once every 10, 1 out of 10. Okay, 1 out of 10. All right, so that's the number that we're going to put in front of our t. Now, if we put a 1/10 in front of our t, we need to put the reciprocal on the inside of the parentheses. So the reciprocal of 1 over 10 would be 10 over 1, or just 10. Okay, and now what we're going to do is we're going to rewrite our equation, pretty much how we see it. But we're going to take what's in the parentheses again and just plug that in our calculator. So when you plug in 1.024 to the 10th power, looks like in the answer choices they rounded to 4 decimal places, so I'll put 1.2677. Okay, that's what you get when you plug this into your calculator. And I'm going to bring down the 1/10 t. Now, 1/10 t, right? If I took this t and put it over 1, doesn't that really just give me t over 10, right? If you multiply the tops, multiply the bottoms. So I'm actually going to erase this and rewrite this as t over 10. Because by doing so, it actually is going to match up with the answer choice. So choice 4 is what we see here, okay? All right, number 6. Suppose a company's revenue increased by 3.88% over the previous year. Okay, now we don't know what the initial value was, right? When we look at the exponential growth formula, we don't know what the initial value is, but what we do know is that within the parentheses, if we normally have 1 plus the rate, we would have 1 plus, if I move this decimal place back twice, 0.0388. So if we add those numbers together, 1 plus 0.0388, that gives us 1.0388. Okay, that's what's in our parentheses. And since this is what it's increasing by the previous year, I'm going to make this exponent represent years. You could use y for years, or usually what we do is we just use t for years, but that's up to you. Okay, so assuming this trend continues, which expression could the company use to approximate the percent increase in revenue through a certain number of months, M? So basically what they want us to do is they want us to change from yearly growth rate to monthly growth rate. So since there are 12 months in a year, we're going to be looking at the growth rate 12 times per year. So 12, whatever number we put here is what we always put in front of the t. Okay, let me rewrite this because I didn't leave myself enough room. So what I'm going to do is I'm going to put in front of the t, I'm going to put a 12. And to compensate for putting that there, I'm going to put its reciprocal 1 over 12 on the inside of the parentheses. Okay, so now I'm just going to take this and plug it right into my calculator. And when I do 1.0388 to the 1/12 is equal to 1.033. And I guess I'll bring down my 12t power. Now, if we look at the answer choices, this answer is not here because the exponents are not in terms of t. So let's just think about what this means. 12t means 12 times per year. If you're looking at growth 12 times per year, aren't you technically looking at it every month, right? There's 12 months in a year, so 12 times per year would be every month. So what I can do is I can take this 12t and I can replace it with m per month because that's what they told us to represent months by. Okay, see right here it says months are being represented by m. So this is what we're looking for. So it looks like that is choice 1. All right, so number 7, a study of the annual population of the red-winged blackbird in Fort Mill, South Carolina shows the population B of t can be represented by this given function, where t represents the number of years, so t is the time in years, since the study began. Okay, now it says, in terms of the quarterly growth rate, quarterly rate of growth. Okay, so there's 4 quarters in a year, so that means 4 times per year. So this is the number 4. Is what we're going to put in front of our t right here. So let me put a 4 there. If you put a 4 here, we want to compensate for that by putting the reciprocal of 4, so 1 over 4, on the inside of the parentheses. Okay, so now from here, I'm just going to bring everything down, except what I'm going to do is I'm going to plug this 1.16 to the 1/4 power into my calculator. So when I plug in 1.16 to the 1/4, that gives me I'm just looking at the answer to see what to round to, 0.038. So 1.038 to the 4t power. Now, that answer choice could be there, but it's not, because what they did was they're using Q to represent quarterly growth rate. Now let's think about this. 4t means 4 times per year. If something's growing 4 times per year, isn't it growing every quarter? So isn't this the same as in 4t, the same thing as saying per quarter? So I'm going to erase that 4t, and I'm going to make that into a Q, like they do in the answer choices, to represent quarters. Okay, so that would be choice 2. All right, number 8. Jen invested $5,000 into an account in 2020. This is the amount of money in the account is increasing according to this given formula, where P is the value of the account T years after 2020. Okay, what is the annual rate of growth to the nearest 1/10 of a percent? All right, now one thing I want to point out, they want the annual rate of growth. Annual means yearly, so what's the yearly rate of growth? All right, if you want to find the yearly rate of growth, T represents years. That means we need to get this T all by itself on the outside of the parentheses. Okay, so if we want to get that by itself, remember, you can take an exponent and shift it from the outside to the inside of the parentheses. It's not going to change the value of the expression. So what I'm going to do is I'm going to take this 3 and shift it to the inside of the parentheses. So when I do, this is what it looks like. Okay, I just took it and put it on the inside. Okay, now I'm going to take this 1.0235 to the 3rd power and plug that in my calculator. Okay, and when I do, this is what I get. Now, T represents years. So since we have years all by itself on the outside of the parentheses, this is going to help us find the yearly growth rate. Okay, so you know how in the parentheses it's 1 plus the rate? What that's telling us is that this right here must be the rate. So the rate is equal to 0.07217. And they want us to round that to the nearest 1/10 of a percent. So first thing we have to do, we have to change it to a percent. So we move the decimal 2 places to the right. So that would be 7.217%. And they want it to the nearest 1/10 of a percent. So that's going to wind up being 7.2%. So that's the annual growth rate. Okay, so this right here represents the growth rate 3 times per year. This represents the growth rate annually, 1 time per year. So when we change it to a percent, we get 7.2%. Okay, so in number 9, it says, Frank averaged the 5-year growth rates, I guess, for the population of New York City between the years of 1920 and 2020, and wrote the function that's given here. Okay, where P of T represents the population of New York City, and T is the time in years since 1920. Rewrite Frank's function to determine the annual growth rate of New York City between the years of 1920 and 2020. Okay, so they tell us here that T is the time in years. So on the outside of the parentheses here, since it says T divided by 5, that's the same thing as like 1/5T, 1/5 T. That means this growth rate is being calculated 1 out of every 5 years. So basically, once every 5 years. So if we want to figure out the annual growth rate, we need to get T all by itself on the outside of the parentheses. Okay, so what we're going to do, I rewrote this, but instead of writing this as T/5, I rewrote it as 1/5 T, because if we want to get the T, right, which represents years, all by itself on the outside of the parentheses, we're going to take this 1/5 and we're going to shift it inside the parentheses as an exponent. Okay, so that's what I did here. I took this 1/5, I took the exponent, and just shifted it on the inside of the parentheses. So now that we have the T all by itself, whatever this is equal to within the parentheses is going to give us our yearly or our annual growth rate. All right, so basically just plug in your calculator 1.21 to the 1/5 power. Okay, so when you plug this into your calculator, I just rounded on the paper, it's equal to 1.0389. All right, so it looks like the yearly growth rate is, since this is 1 plus the rate, okay, this right here would be our rate. So the rate is equal to 0.0389. So usually we switch that to a percent, but let's go back and reread the problem and see how they want us to write it. Okay, so I'm realizing on my paper it doesn't say what to round to, but on your paper, I hand wrote in, I wanted you to round to the nearest 100th of a percent. So if you take this decimal and move it twice, that will change it to a percent, and because I want you to round to the nearest 100th of a percent, that's going to wind up being 3.89%. So that right there is the annual growth rate, which just means the yearly growth rate. All right, number 10, since January 1980, the population of the city of Brownville has grown according to the mathematical model, what they gave us right there, and where X is the number of years since January of 1980. All right, so first thing they want us to do is they want us to explain what these two numbers represent in the context of the problem. All right, well, since the 720,500 is in the initial spot of our formula, that number is just going to represent, I don't want to say the initial population. Since they give us a year, it would be the population of the city of Brownville in January of 1980. That was the initial year that they were looking at, this population. Okay, now the next number right here, the 1.022. Now remember, within the parentheses, this represents 1 plus the rate. So what that tells us is that this 0.022 must be our rate. Okay, now remember that to change from a decimal to a percent, we take the decimal and we move it 2 places to the right. So that becomes 2.2%. So that is the rate. And since X represents the number of years, that's the yearly growth rate. So basically what's happening is the population in this city is growing by 2.2% every year since January of 1980. And it's really important in your explanation to say every year. It doesn't just happen, it wasn't just like a 2.2% increase over, throughout the years. That happens every single year. Okay, so I just wrote that 1.022 represents a growth rate in the population of Brownville by 2.2% per year. Okay, so in the next part, if you start here, if this trend continues, use the model to predict the year during which the population of Brownville will reach this number. So what we're going to do is, if we want to figure out how long, right, during which year it'll take to reach this number, we're going to plug in this number into the left-hand side of the equation. We're going to plug this in. I don't want to say for the ending amount, but this is the amount after a certain time period has lasted. So if we plug in this number for y, we're going to solve for x. We're going to solve for the years. All right, so we know whenever we're solving for an exponent, we're going to have to use logs. But before we do so, we have to get the base that contains its exponent by itself. So let's get rid of the 720,500 by dividing both sides of the equation by that number. Okay, now on the left-hand side of the equation, if you plug in the 1,548,800 divided by this number right here, it'll give you a decimal in your calculator. But since this started off as a fraction, if you hit math, enter, enter, it'll change it into a fraction in simplest form for you. So that fraction simplifies to, 1,408 over 655. So at least I'm using the exact number rather than a rounded decimal. Okay, and then these cancel, leaving us with 1.022 to the x power. Okay, now that we got this base by itself that contains the variable exponent that we're solving for, now we could put the word log in front of both sides of the equation. Because by doing that, we're allowed to take the exponent and bring it to the front of the word log. So on the right-hand side of the equation, we have x times log of 1.022. And then I'm just going to bring down the left-hand side of the equation. And if you prefer to put this in parentheses, you can, just because when you plug it in your calculator, you'll have parentheses, but you don't have to on paper. That's up to you. Okay, so if we want to get this x by itself, we need to get rid of the log of 1.022. And since x is being multiplied by this, the opposite of multiplication is division. So we're going to divide both sides of the equation by log of 1.022. Again, if you want parentheses around this number, you could put it. If you don't need it. But your calculator gives it to you, so. Okay, so on the right-hand side of the equation, those cancel and leaves us with x. And this, you're just going to plug in your calculator exactly like you see it. Don't forget to put the word log. Don't forget to close your parentheses. And when you do, you get, I'm just going to round for right now, you get approximately 35.1672. Okay. Now, they don't want to know how many years will it take to reach this number, okay? They want to know which year, predict the year during which this population, during which the population will reach this number. So it happens within the 35th year. I mean, no matter what your decimal is, even if it was 35.8 or 35.9, it still happens within the 35th year. So what we're going to do is we're going to take 1980, okay, the year that the population was this original number, and we're going to add on the 35 years that it took to grow to reach this number, and that'll give us the year itself that happens, which is 2015. Number 11, Melissa invests $10,000 in a bank. The bank pays 3% interest compounded monthly. All right, I'm going to stop for a minute. When we see compounded followed by anything other than continuously, okay, that tells us that we're going to need to use our compound interest formula. So this is the formula we're going to be using. And I guess we'll keep reading to figure out what to plug in where. Okay, to the nearest 10th of a year, how long must she leave the money in the bank for it to increase by $4,000? Now, because they're asking how long, they're looking for the time, they're asking us to solve for t. Okay, so that means we have to plug in numbers for everything else. All right, so let's see. Let's start at the beginning. Melissa invests $10,000. So that's going to go in for the P. Okay, that's the initial amount. I'm going to actually just bring my equation over here, though. So in place of P, I'm plugging in $10,000. Okay, then we have 1 plus. The bank pays 3%. So if you take the number 3 and move the decimal place back twice, or if you take 3 and divide by 100, it'll give you 0.03. So it pays 3% interest compounded monthly. Since there's 12 months in a year, and the number of compounds a year would be 12. Okay, so that's going to be 12. And we already said we're solving for t, so I'm going to leave that as a t. And they want to know how long she must leave the money in the bank for it to increase by $4,000. Okay, well, if she has $10,000, if she's investing $10,000, if she wants it to increase by $4,000, it just means she wants it to go up by $4,000. So $10,000 plus $4,000 would be $14,000. Okay, we're going to put that on this side of the equation because this is the amount that she's going to have after a certain time has passed. All right, so now we're solving for an exponent, and we know when we do that, we're going to have to eventually use logs. But let's get this base that contains the exponent by itself first before we use logs. So we have to get rid of the 10,000. So let's divide both sides of the equation by 10,000. So this actually works out to be a nice clean decimal. This divided by this is just 1.4. So I'm going to write it like that. All right, so that's supposed to be a decimal point. 1.4 equals, and let's see, we're going to have 1 plus 0.03 divided by 12 to the 12t power. So now that we got this base that contains the exponent on it by itself, now this is where we could put the word log in front of both sides of the equation. And the reason we do that is because the power rule tells us you could take the power and move it to the front of the word log. So that'll leave us with 12t times log of what's in that parenthesis. Okay, so that's the right-hand side of the equation. And on the left-hand side of the equation, let's just bring it down. Log. Let's see if I can make the decimal better this time. There we go. A little smaller, 1.4. Okay, so since the t is being multiplied by 12 and is also being multiplied by log of this parenthesis, we need to divide by log of this parenthesis as well as divide by 12 to get t by itself. I'm first going to divide by log, although it doesn't matter which one you divide by first. I'm going to first divide by log of 1 plus 0.03 divided by 12 on both sides. Okay, so those cancel, and I can bring down the 12t. And then here, you just have to plug this in your calculator. Now, when you do, you're going to have to round on your paper, but keep that exact number in your calculator because when you divide by 12, you want to make sure you're dividing that whole number by 12, not the rounded version of it. Okay, so the rounded version is 134.7571. So now, since we have to divide by 12, again, in your calculator, you're just going to hit divided by 12. Okay, that way it takes the whole entire, number and divides it by 12. So when we do, we get t to be approximately 11.2298. Okay, so let me go back and reread. It says, to the nearest 10th of a year, how long must she leave the money in the bank for it to increase by 4,000? All right, so they just want us to take this and round it to the nearest 10th. So to the nearest 10th, this is going to be 11.2 years. Number 12, Mike's parents told him that when he graduates from high school, they will give him $10,000 to put into his retirement fund. He has two financial planners assuring him that they have the best plan. All right, so let's see. We have Mr. McCaffrey's plan will earn him 3.98% interest compounded quarterly. So we know when we see compounded, anything other than continuously, we're going to use our compound interest formula, which I'm going to write right here. Okay, and then I'm just going to keep reading. It says, Mr. Baglino's plan will earn him 4.02% interest compounded continuously. So this time we see the word continuously. So we know when we see the word continuously, that's when we use a PERT. That's supposed to be an E, sorry, that came out a little squished. Okay, so it says to write two functions, M of t, I guess for McCaffrey's plan, and B of t for Baglino's plan over time that calculates the value of each account after 2 years. Okay, so let's do it. So let's start with M of t. So this is McCaffrey's plan. So McCaffrey's plan in terms of time. Okay, this is a function because it's M of t. All right, so in place of the P, the initial amount, we're going to plug in 10,000. And then we have 1 plus. So the rate is 3.98%. So if we move the decimal place back twice, it'll become 0.0398. And then compounded quarterly. Quarterly means 4 times a year. So in place of n, the number of compounds a year, we're going to put a 4. Okay, and we're going to leave that in terms of t. So this is the equation for McCaffrey's plan. All right, now for Mr. Baglino's plan. So B of t, Baglino's plan in terms of time, would be equal to, okay, so the P, the initial amount, is still the same. The base is E because it says continuously. And this time the rate, I should have underlined that before, is 4.02%. So if I move the decimal place back twice, that'll be 0.0402. I can't get my pen to work. There we go. And T. Okay, we leave it in terms of T. So for part A, that's it. All right, part B. Mike would like his account balance to be $100,000 when he retires. If he does not add any more money to the account, how long will it take to the nearest 10th of a year for him to retire if he chooses Mr. McCaffrey's plan? Okay, so here's Mr. McCaffrey's plan, and they want us to figure out how long will it take to the nearest 10th of a year. So we're looking for the T. We're looking for the time. So if we're looking for the time, what we're going to do is we're going to replace this M of T with something. All right, well, he wants his account balance to be $100,000. So we're going to put that in place of M of T. All right, so let me erase that. And we'll plug in $100,000. Okay, so in order to solve, the first thing we're going to do is we're going to divide both sides of the equation by 10,000. Okay, we want to get rid of that number in front of our parenthesis. All right, so on the right-hand side of the equation, those cancel, leaving us with 1 plus 0.0398 over 4 to the 4t power. And on the left-hand side of the equation, I'm going to do it like this. I'm going to cross off a 0 on top with a 0 on the bottom, another one on top with another on bottom. I'm going to keep going this with this, this with this, and it leaves us with 10 over 1, which is just 10. Okay, now, since we're solving for an exponent, we know we need to use log. So I'm going to put log in front of both sides of the equation. And the reason I do that is because the power rule tells me I can take this power, or this exponent, and bring it in front of the word log. Okay, so again, all I did was I took this exponent and brought it in front of the word log. So here it is. So if we want to get the t by itself, we have to divide by log of this parenthesis as well as by 4. Okay, so let's do that. I'm going to divide by log of that parenthesis. Sorry, it takes me a minute to write that out, right? All right, so on the left hand, well, let me start with the right. On the right-hand side of the equation, these cancel off, so I could bring down the 4t. And on the left-hand side of the equation, I just have to plug that in my calculator, And when I do, I'm just going to round, let's see, I get about 232.56, I'm going to keep going, 498. Okay, so then just divide both sides by 4, and I will have the t all by itself. So those cancel. So it leaves me with t is approximately, let's see, 58.1412. Okay, so if we go back to the question, they said up here they wanted us to round to the nearest tenth of a year. So this would round to 58.1 years. And make sure you write your units, right? Make sure you put the word years afterwards. If you don't have your units, it's not completely correct. All right, letter C. Mike would like his account balance to be $100,000 when he retires. Okay, so just like the last part. If he does not add any more money to the account, how long will it take to the nearest tenth for him to retire if he chooses Mr. Bellino's plan? Okay, so just like in part B, we're going to replace the left-hand side of the equation with 100,000, and then we're just going to solve. All right, so let's first divide both sides of the equation by 10,000. So that's going to leave us with 10, again, equals e to the 0.0402 t power. And then whenever you have an e, to get rid of the e, we want to throw ln in front of both sides of the equation. Okay, and the reason why is because ln of e to any power is going to leave you with just whatever that power was. So I'm going to cross this off, and I'm going to write 0.0402t on the right-hand side of the equation. And on the left-hand side of the equation, I'm just going to bring down the ln of 10. So then, to get t by itself, you can just divide both sides of the equation by 0.0402. And you can just plug this in the calculator. All right, when you do, you get approximately, let's see, 57.2782. And going back to the question, it says they want you to round to the nearest tenth of a year. So that would round up to 57.3 years. And again, remember to always put your units, okay? Don't just leave it at 57.3, because what does that mean? 57.3 months, hours. Okay, so make sure you put the units. Number 13, a rabbit population doubles every 2 weeks. All right, so since we see this word doubles, that's cluing me in as to the fact that we're going to use the doubling formula. Okay, it says that the rabbit population doubles every 2 weeks. Okay, so 2 weeks, so that's the doubling period. So I could plug in 2 for the D. So let me just do this. I'm going to just bring down this, and I can replace the D with a 2. Okay, so it says there are currently 8 rabbits, so that's the initial number of rabbits. So the initial always goes in for the P, so I'm going to replace the P with an 8. If T represents the time in weeks, and P of T is the population of rabbits with respect to time. So they're telling us P of T, the population of rabbits with respect to time. Instead of using an A, they want us to use P of T. They want to know about how many rabbits will there be in 77 days. Okay, so this is the time that we're looking at. The only thing is that this is in days, whereas over here, the doubling period was in terms of weeks. So since I plugged it into the formula in terms of weeks, right, 2 weeks, I need to convert this to weeks. So if I take 77 days and divide it by the number of days in a week, that'll tell me that we're talking about 11 weeks. So I'm going to replace the time with 11. Okay, so I'm going to replace this time right here with 11. And if I replace this T with 11, I really shouldn't leave this as P of T, right? This right here. I should also be replacing this T with an 11 because we're finding P of 11. Okay, so now all you're really going to do is just plug this into your calculator. All right, so when I do, I get approximately 362.0387. Okay, now here's the deal. We can't have a decimal of a rabbit, right? So that's probably why they say about how many. It's not exactly. So we're going to have about, right here, 362 rabbits. All right, and then finally, number 14. All right, so I see the word half-life as soon as I read this. So right away, I know I'm going to be using my half-life formula. All right, so there we go. I'll put it over here. All right, so it says, let's just read it now. The half-life of a radioactive substance is 12 years. All right, let me just underline the half-life is 12 years. Write an equation that can be used to determine the amount S of T of 500 grams of the substance that remains after T years. All right, so first thing they want us to do is they want us to write an equation, and it's in function form. So S of T, sorry about that, S of T equals, so I guess that means the amount of substance in terms of time is equal to. All right, now in place of the P, we're going to plug in 500 because that's the original amount. And then I'm going to bring down the 1/2. Now we want to leave it in terms of T, right? Because they say remaining after T years. So I'm going to leave that T as a T. And we're going to divide that by H, which is the half-life. So we said the half-life is 12 years. So we're going to divide that by 12. So this is the first part. We're actually done, okay? On a quiz or a test, we'd get a point just for writing that, just for plugging in the numbers. Now it also says determine algebraically to the nearest year. I like to underline what to round to. How long it will take for 25% of this substance to remain. Now we're looking for how long, so we're looking for the time. So we know we're going to have to leave that as a T. You know what I'm going to do? I'm going to rewrite what we know. So I know this is 500. I know this is 1/2. The T is what we're looking for, right? Because we're looking for how long. And the half-life is 12. So it looks like we're going to have to plug in a number for the left-hand side of the equation. So we have to plug in something for S of T. So we want to know how long it will take for 25% of this substance to remain. Well, if we started off with 500 grams, we have to figure out what's 25%, so 0.25, of 500. So just multiply it by 500. All right, when you do, that gives you 125. So 125 grams is 25% of the original substance. So that's what I'm going to plug in for S of T. We want to know how long will it take for the original 500 grams to go down to 125 grams. All right, so let's solve it. So in order to solve, we would first divide both sides by 500. So 125 divided by 500 is 0.25. The 500s cancel off, so I bring down the 1/2 to the T over 12 power. Okay, so now we're going to put the word log in front of both sides of the equation. And the reason we do that is because the power rule tells us we could take this power, we could take this exponent and bring it in front of the word log. So that leaves us with log of 0.25 equals T over 12 times log of 1/2. Okay, so we have to get rid of the T on both sides of the equation. So I'm going to first get rid of this log of 1/2 by just dividing both sides of the equation by log of 1/2. All right, so what happens is those cancel, and I can bring down the T over 12. And then on the left-hand side of the equation, I'm going to have to plug this in my calculator. So when I do, actually it works out to be exactly 2. Log of 0.25 divided by log of 1/2 is 2. Okay, so to finish solving, you could do a few different things. I'm just going to put the 2 over 1, and then I'm just going to cross multiply. So T times 1 is T. Bring down the equal sign, and then 2 times 12 is 24. So the time it takes is 24. But 24 what? We have to go back and look at the units. Well, T is representing years, so this would be 24 years. And just a reminder to everyone, you do have to memorize all these formulas for the quiz, okay? You have to know all your formulas. Half-life, doubling, compound interest formula, compounding continuously, your regular exponential growth and decay formulas. So please make sure you take the time to memorize all these.